Now, I mentioned earlier that numeric features pretty much work out of the box for almost any algorithm, although we do need to have some consideration around their distribution. Categorical features are not the case, though. Often, in most algorithms that we're going to run into, we need to do some kind of modification of our categorical features to turn them into numeric values that can be used within a model. Now, this is not always the case. There are certain models that will work naturally with categorical features. For example, any of the decision tree type of algorithms, such as regular decision trees, random forest, gradient boosted machines, they can often work with categorical features. But then there's a lot of algorithms that just can't do anything with categorical features. The way that they are constructed or the way that the math works underneath those algorithms requires them to be of some type of numeric value. So we need to make some modifications. All right. So recall the linear regression that you learned in the last module. And the algorithm for linear regression is this y equals beta naught, the intercept, plus the coefficient beta 1 for feature 1, plus the coefficient for feature number 2, and so on all the way to the number of features that we have. Now, the only way that this algorithm actually works is if our numeric feature is, or excuse me, our predictor variable is a numeric value, right? We can't actually use this algorithm in any way for an actual non-numeric value. And now we even talked about this in previous lessons, that linear regression, the actual function within R, will do a modification of categorical features to make them numeric, right? And so this is actually a process that we can apply directly for many other algorithms that have this requirement. So the two most common ways to take a categorical feature and turn it into a numeric are what we call dummy encoding and one-hot encoding. Now, these are almost the exact same thing. One-hot encoding, dummy encoding is just a slight modification of one-hot encoding. So the idea here is, let's look at the slide, and we see that there's this feature, X, where the values that it can take on are A, B, and C, right? But these are non-numeric, and so we need to do some modification to turn these into numeric features. Well, one-hot encoding, what that does is literally take each of these unique values that X can be and turn them into their own column, right? So here we have a column for X equals A, X equals B, and X equals C. And what we do is we simply put a 1 under that column that was the original value for X, and then the other columns are 0, right? So this is just a numeric indication of which of the values was X originally. Was it A? Then if it is, then you get 1 under that column and you get 0 under the other ones. Now, dummy encoding is basically taking the same thing, but we need to remove one of the columns, right? And this is for some reasons we're not going to get into, but basically it creates what's called perfect linearity, and certain algorithms can have some big problems when we have perfect linearity, or they can't even do the computation. Linear regression is one of those algorithms that we need to remove one of the columns just because of the way that the math works for linear regression. Right, so here dummy encoding is the exact same thing as one-hot encoding up here, except we have removed this X equals C. That is our reference variable. Now, that should sound familiar because that's what we talked about in the linear regression lesson, where we apply a categorical variable and we have the coefficients are relative to that reference level that we have removed. All right, so that is one way that we can actually convert a categorical feature into a numeric value. Now, an example of this, if we want to look at the Ames data, is with the neighborhood. So there is a neighborhood variable that we can use. So you think about, we're trying to predict the sale price of a home. Well, neighborhood is obviously probably a feature that's pretty important, right? Because the neighborhood is, often a pretty big indicator of a relative range of the price that the home could be. Well, here we have basically neighborhoods that range from Briardale, North Park Villa, Sawyer West, North Ames, and I believe there's something like 27 different neighborhoods in this data set. So in order to convert this into some type of numeric feature that we can use in our models, right? We could do dummy encoding, which we have now taken each neighborhood, and each unique neighborhood within the Ames data now becomes its own column: neighborhood Blust, neighborhood Briardale, neighborhood Brookside, neighborhood Clear Creek, and so on. You can see this goes all the way across. We created a new column for each unique neighborhood. And then for that given observation, we just put a 1 for which neighborhood it actually is, and all of the other neighborhoods get 0. Right? So when we do this, we actually created 27 new features through dummy encoding. Now, one-hot encoding is doing the exact same thing, except we now have created 28 features because we didn't remove one of the neighborhoods to be a reference variable. And actually, the one that got removed when we did dummy encoding, you can see this, it was this first one, Bloomington Heights. And that's just kind of a way that R typically works, is it takes the first value, either factor level or alphabetical value in that given categorical feature. And when you do dummy encoding, you remove that first level or value to be the reference value. Now, how do we apply dummy coding and one-hot encoding? Well, there is a step dummy function that we can use. So here I'm going to add onto my recipe, and I'm going to do dummy encoding, and I'm going to do all nominal. So that means all categorical features. Now here, this is where we can change this from being dummy encoded to one-hot encoded. There is a one-hot argument that we can pass. It's Boolean, true or false. And this will tell it, do I want to have it one-hot encoded, or do I want to have it dummy encoded? Now, there are some algorithms or engines, packages that automate this process for us. So this is kind of where it gets a little bit confusing in the R ecosystem, is that some packages or algorithms will automatically do some type of dummy encoding or one-hot encoding for you, where others will not. And you'll get an error, and it will say that there's non-numeric features trying to be used, which this algorithm cannot be used for that. So you would have to modify. So often what makes sense is that we create a recipe that is going to be consistent and can be used consistently across many algorithms, right? So if you do choose to do some kind of dummy or one-hot encoding, even if the algorithm is not required, sometimes it's good practice to go ahead and add that to the recipe to make it explicit that we are doing this to the data for feature engineering prior to applying the model. All right, so dummy and one-hot encoding are not always the best approaches to use. And this comes into play when we have a lot of categorical features, or we have what's called high cardinality. That means we have, within a given categorical feature, we have many values, or like what we saw back here, we have many neighborhoods. Or if we have ordinal features. Now, we're going to get to ordinal features here in just a second, but here, the main thing to think about is when we have a lot of categorical features, or our categorical features have many levels that they take on. The problem with dummy encoding and one-hot encoding is that it makes our features extremely wide. It adds many, many more features. For example, when we simply one-hot encoded a single feature, the neighborhood within Ames, we went from having one feature, neighborhood, to having 28 features, right? Because it's one for each neighborhood. So you can see how if you did this for many features, and these features had several levels, you could end up creating potentially hundreds of new features. And this can cause additional problems depending on the algorithm that we're using. So often there are some other ways to take a categorical feature and turn it into numeric that's more efficient and better to use than simply one hot encoding or dummy encoding.